Hey guys, welcome to my YouTube channel. And the question for today is maximum points you can obtain from cards. So there are several cards that are arranged in row, and each card has an associated number of points. The points are given in the integer array card points only. So basically, we are having several cards, and that cards and every card has a points associated with it, and basically the points are in the array given to us card points. All right, in one step we can take one card either from beginning or from the end of the row. Let us take, if we have the like 1 2 3 4 cards, so either we can choose this or we can choose this. All right, so what's the criteria and how many cards to take? We will be given that, because we have to take exactly k cards, and the score will be that the sum of the points, basically the sum of the numbers, that would be the score, and we have to return the maximum score obtained. Alright, so if this is the case and we can obtain two cards, then obviously we will pick 4 and 3, because 4 plus 3 is 7. Alright, now suppose the case is 1 1 200 100 and 10 and 1. So if you have to pick one card, can we pick this card? No, we have to pick from either from beginning or from end, and move our case likewise. All right, I hope this part is clear. The statement of the question is clear as well. All right, and the example that I have just explained is clear as well. All right, now let's see the further examples that are given to us in the question. All right, so for the k equals to 3, the 3 cards selected is 1, then 6, and then 5. Where it's not like we have 1 2 3, because they will give us the less total. So 6 plus 5 11, and 11 plus 1 12. So this would give us 12. All right, so basically we have to return the sum, that is the maximum sum. I hope this example is clear as well. That's the same 2 to 2, any two, either this or that we can pick and gives the same result. Similarly for this, we can pick all, because we have the k value is 7. All right, so k can be the size as well. All right, and similarly this case we cannot pick the maximum, we have to either pick from beginning and end, then we have to move. All right, I hope this point is clear as well. So let's see the constraints that are given to us. The constraint given to us in this case are that the length of the array could be from 1 to 10 to the power 5, and k would also be from 1 to the length of the card. All right, so they won't be asking us to select this many cards, even if the array size is 2. All right, and one more thing, that the array is not from 0, so we don't have to put the check for the 0 1. All right, I hope the question statement is clear to everyone, as well as the examples. Now the initial idea that we can deduce from this is a two pointer approach, basically selecting which one is the maximum. But can this always be the case? All right, now listen, when this kind of condition will fail, suppose 1 and 1 is here, and here we have 1000, and here we have only 5, and then 4 and 4, and we have to pick two numbers. All right, suppose three numbers. All right, so we pick this, or we decide what to pick. So both are same, we pick this. Suppose we say we can pick anyone, because both are same. No, it will matter that we will have to pick this. So we have to take care of the every possibilities, and that will help us determine the answer. This is a kind of a hint for this question. Some of you might be thinking of the comparison approach, but this approach won't work here. I have told you with this example why it won't work here. All right, and it means that we have to list all the possibilities and we have to see for them. Now let's see how we are going to do this thing in a much more optimized way. All right, so with this example, I hope the approach would be clear and how we're going to solve it. All right, now let's see how we are going to solve this question. All right, so basically this is the array that is given to us with the points, and the value k is given to us, that is 6 over here. All right, so initially what we will be doing is we will be taking the sum of the first 6 digits from here, 1 2 3 4 5 6. So 4 plus 5 9, 9 plus 9 18, and 16 plus 2 also 18, 18 plus 18 36, and 36 plus 10 will give us 46. All right, so initially we will take the sum of the first k numbers, alright. And that is 46, alright. Now what we will be doing is simultaneously we will be, when taken the sum of the first 6 numbers, now what we will be doing is, suppose here we have the sum that is 46, alright. Yeah, so what we will be doing is, now we will keep on subtracting this number and keep on adding this. Why we are doing this? Because we will consider every possibility, alright. As soon as we subtract we subtract 10, that is 36, and add 3, we get the result 39. Now since this is the highest, it would be stored, alright. If any number that we get highest from this, then what we will be doing is, we will be just updating our highest variable. Now the sum is 39 and highest is 46, alright. Now removing this, alright, from 39 minus 2 would be 37, and 37 plus 12 would be 49. Alright, since 49 is greater than the highest, then we will update highest to 49, and now sum to 49 as well, alright. Now again we subtract 16 from it, and we will add 5 to it, alright. So on subtracting 16 from this number, we will get is 15, 6, 9, 6, 3 and 4, 4, 1, 3, 33. We get 33, and 33 plus 5 that we get is 38, alright. So 38 is lower than the highest, so it won't be updated, and similarly the sum would be updated to 38, alright. Now we have removed these numbers and we have added numbers up to here, alright. Now removing 9 from 38 will give us 31, and adding 31 to it, that would give us 62. Then 62 is greater than the highest, so highest would be updated now to 62, and as well as the sum is updated as well, alright. So now we will remain with 5, alright, and we'll see that on removing 5 from this, we will get 57. Since 57 plus 7, that is 64, that it's greater than the highest, so we will update highest again to 64, alright. Now we will subtract 64 from it, and we'll get the answer 60, and then we will add 7 to it, so which will give us the answer 67. So we can see that this would give us the highest total as compared to this numbers, alright. And since at any point basically this approach is called the sliding window approach. So at any point we all have the 6 numbers. If we are removing one number, then we are adding the number instead of it, alright. We are not just removing the number and not adding it. So we are maintaining our window of 6 digits every time, alright. And how that's updated, so in the first go we take all the numbers and we simultaneously update them with these numbers that could have been taken instead of them, alright. And we are updating from this direction. Why? Because if we take this number in one go, then we have to always take the number from here, because we cannot take a number from the middle, right? I hope this approach is clear as well, and this is known as the sliding window approach that we are using here. It will cover all the test cases in a much more optimized way, alright. I hope this is clear, and the space complexity for this code would be over 1, because we are storing the results in the sum variable and the highest variable, and that would be constant memory space. We are not requiring any extra array for this, and also the time complexity would be O of k. So if k goes to n, then the time complexity will be O of n in the first case. Otherwise it would be O of k depending upon the size of the k and the size of the window, alright. As such, no window is there, just we are maintaining the sum. If you want for the easy purpose, you can maintain a window of the array and calculate it sum likewise, but this will be a lengthy process, alright. I hope this approach is clear to everyone. If you are still facing any kind of difficulty, then when we will see the code for this problem, I hope that would be clear, alright. Now let's see the code, and if any of you is still facing any kind of difficulty, it would be clear then, alright. Now let's move to the code for this question. So here is the code for the question, alright. That's the total variable and that's going to store the sum, alright. Initially we get the sum for the first k numbers that will be present, alright, depending upon the k, alright. Now we have taken the best variable that will be storing only the highest value and which would be returned in the end. Alright. Now the main algo comes over here. Alright. So what we are doing is one by one we are adding the numbers from the end, that is from the jth position, and subtracting from the ith position. Ith would be the k minus 1th position in the array, right? And I would go to 0, I will decrease and j will also decrease, alright? So basically 1 is subtracted, 1 is added, 1 is subtracted, 1 is added. Likewise, and at every point we are just having the comparison for the maximum of both. So at the end we will have the maximum value. We will take all the cases in the loop and we will see that which of us gives the maximum answer. Alright, I hope it's clear. Now let's try to submit this. As you can see, it's accepted. So if you are facing still any kind of difficulty, please feel free to reach me in the comment section. I will surely reply to every one of you. Alright. And if you like this video, please press the like button, share it among your friends and subscribe to my YouTube channel. Thank you for watching. Bye bye.